Whitefield Diffie and Martin Hellman developed Diffie-Hellman key exchange algorithms in 1976 to overcome the problem of key agreement and exchange. It enables two parties who want to communicate with each other to agree on symmetric key, a key that can be used for encryption and decryption. Note that Diffie-Hellman key exchange algorithm can be used for only key exchange, not for encryption and decryption process. And this algorithm is based on mathematical principles. This algorithm is based on elliptic curve cryptography, which is a method of doing public key cryptography based on algebra structures of elliptic curves over finite fields. This algorithm also uses the trapdoor function just like many other ways to do public key cryptography. And the simple idea of understanding the Diffie-Hellman algorithm is given here. Diffie-Hellman algorithm is primarily a protocol that is used for key exchange. Using this interactive protocol, two parties will derive a common secret key by communicating each other. For the sake of simplicity and practical implementation of the algorithm, we will consider only four variables. One prime number p and g, which is a primitive root of p, and two private variables a and b. P and g are both publicly available numbers. Users Alice and Bob pick private values a and b, and they generate a key and exchange it publicly. The opposite person receives the key and generates a secret key, after which they have the same secret key to encrypt. Now let's see the algorithm. Alice and Bob agree to use a prime number p equals 23 and primitive root g equals 5. The next step is for Alice to pick a secret integer a, and she does not reveal to anyone, while at the same time Bob picks an integer b and keeps it secret. Now Bob and Alice use their secret integers to compute, whereas the value of a and b is only known to Alice and Bob. Alice computes this using a formula a equivalent to g raised to a mod p. Similarly, Bob computes this value using a formula b equivalent to g raised to b mod p. They next exchange these computed values. Alice sends a to Bob and Bob sends b to Alice. Note that these values are sent over the insecure communication channel. Finally, Bob and Alice again use their secret integers to compute. Alice computes this as a dash, which is equivalent to b raised to a mod p. Similarly, Bob computes this as b dash, which is equivalent to a raised to b mod p. The values they compute a dash and b dash are actually the same, since it is given here, and this common value is their exchanged key. Alice and Bob both use public numbers p equals 23 and g equals 5. Alice and Bob select a private key a and b respectively. A holds the number 4 and b holds the number 3. Both Alice and Bob now calculate the value of a and b. We use this formula to compute the values of a and b. Now both Alice and Bob exchange the public numbers with each other. Alice and Bob receives the public key 4 and 10 respectively. Now Alice and Bob calculate the symmetric keys using this formula. The secret key generated by Alice and Bob is 18. Since both the keys generated are equal, the Diffie-Hellman exchange is valid. Now let's move on to the program. Here we are implementing the Java code for Diffie-Hellman algorithm. This line of code will create a class to calculate the key for two persons. This line of code is the point from where the program starts its execution, or simply the entry point of Java program, which is the main method. The Java compiler or Java virtual machine looks for this main method when it starts executing a Java program. Every word in this statement has got a meaning to JVM. Main is a method which accepts a string array in command prompt. Public means you will access anywhere. It is an access modifier which specifies from where and who can access the method. Making the main method public makes it globally available. It is made public so that JVM can invoke it from outside the class. Static is a keyword. Static is an access modifier. We can call the method directly by the class name without creating its objects. Static is mainly used for main method because we can call the main method only one time, which is fixed, which means there is only one copy of main function is available. So when the program is started, the static method has to execute first. So when we set a main method as static, then it will execute first. Void is a keyword and it is used to specify that a method doesn't return anything. It is a return type. Every method in Java is declared with return type and it is mandatory for all Java methods. So the main method does not return any value. As soon as the main method terminates, the Java program terminates too. Main is a method name, and here is where our program starts to execute. It is the name of the Java main method and it is an identifier. In Java, we accept only string type of argument and store it. String args means an array of sequence of characters, that is strings that are passed to the main function. Arg is the name of an array and it can be anything like argument or arg, A or A, anything like that. So args is not special, you could name it in anything else. A string is a data type which supports all the primitive data types like int, long, float, double, byte, short, character in Java. In public static void main string args, args is an array of console line argument whose data type is string. In this array, you can store various string arguments by invoking them at command line. So args is an array of all parameters used in this program, or all the values passed in the program are stored in this array. And it is string because string can accept all values. The int keyword is a data type that can store whole numbers. It is a primitive data type, specifies the size and type of variable values. So it stores integers or whole numbers without decimals. Here we are assigning a value to a variable. Int is a data type and variable name is p. The equal sign is used to assign value to the variable. In this program, we consider only 4 variables. A prime number p is taken and it is assigned a value 23, and a primitive root of p is named as g and assigned a value 5. A prime number or a prime is a natural number greater than 1 that is not a product of two smaller natural numbers. A natural number greater than 1 that is not a prime is called a composite number. For example, 5 is prime because the only way of writing it as a product 1 times 5 or 5 times 1 involve 5 itself. However, 4 is composite because it is product of 2 times 2 in which both numbers are smaller than 4. The primitive root of prime number is a concept in number theory and is used in cryptographic applications. We will see the method of finding the primitive root in upcoming videos. Here we have selected the prime number 23 and it has 10 primitive roots 1. And variables a and b are assigned a values 4 and 3 respectively. P and G are publicly available numbers. A and B are private key, whereas A and B are known only to Alice and Bob respectively. So the variable P stores the value 23, G stores the value 5, A stores the value 4, and B stores the value 3. The double keyword is a primitive data type. It is used to declare the variable and methods. It generally represents the decimal numbers. Double is more precise than float and can store up to 64 bits, whereas float can store up to 32 bits. This line of code will calculate the public key for Alice. Math.pow method returns the value of x to the power of y. The math.pow method is used to return the value of first argument raised to the power of second argument. The return type of pow method is double. And we are storing the returned double result to Alice cents. This method, that is math.pow, will return a value of g raised to power a and which will return some value, right? And that value on computing g to power a is a dividend and p is the divisor. The modulus operator returns the remainder of two numbers after division. After computing g raised to a mod p, there will be a remainder of this division, and that remainder is the value of public key. So this is how we calculate the public key for Alice and Bob. As you see here, g is 5, a is 4, and p is 23. To calculate the public key on sender side, we use this formula. Now the g value is 5. The private key value on sender side is 4. 5 raised to 4 gives 625. 625 is the dividend and 23 is the divisor. On evaluating this, the remainder is 4. So 4 is the public key generated by Alice. Similarly, on the receiver side, we calculate the public key. The G value is 5 and the private key value on receiver side is 3. 5 raised to 3 gives 125. 125 is the dividend and 23 is divisor. On computing this, we will have a remainder 10, which is the public key on receiver side. Now Alice and Bob exchange their public key with each other and they will calculate the secret key. To calculate the secret key, they use this formula. That is the shared public key raised to the power of private key mod p. Alice computes its secret key. 10 is the public key generated by Bob and it sends to Alice. 10 raised to 4, 4 is the private key of Alice and this will give 10,000. On dividing 10,000 with 23, we will get the remainder 18. Similarly, Bob computes its secret key. 4 is the public key generated by Alice and it sends to Bob. 4 raised to 3, 3 is the private key of Bob 4 raised to 3 gives 64. On dividing 64 with 23, we will get a remainder 18. And you can see the Alice and Bob secret key are same. This line of code will generate a secret key for the receiver side, that is the public key generated by Alice is sent to Bob. And thus we are storing the return double result to Bob computes. This line of code will calculate the public key for Bob and we are storing the return double result to Bob sends. This line of code will generate a secret key on sender side, that is the public key generated by Bob is sent to Alice. And we are storing the return double result to Alice computes. So this part of code will calculate the public key for both sender and receiver, as well as we are exchanging the public key between them. Now we have generated the secret key on both sides. To check whether the value of secret key generated by Alice and Bob is identical, we're going to compute the value of secret key using this line, and we will store the secret key to shared secret. Using if statement, we are comparing the value of secret key. Here the double equals operator is used to check the equality of two variables. So this condition checks the value of Alice computes and shared secret are equal, and this condition checks the values of Alice computes and Bob computes are equal. And this is the type of logical operator and it is read as and or logical and. This operator is used to perform logical AND operation, that is function similar to AND gate in digital electronics. As you can see, there are two statements or two conditions separated by this operator. This operator evaluates two statements and returns true only when both the statements are true. Since both the keys generated are equal, the Diffie-Hellman exchange is valid. This statement is used to display a message, string or data on the screen. System is a built-in Java class that contains useful members such as out, which is short for output. The println method is short for println, which will print a value to the screen or file. And here we simply pass the string that we want to display as output. The println method is often used to display variables. To combine both text and variable, we use this character. If the generated secret key is identical, then this line will display this text along with this variable value. If not, it will print this error message. Now let's execute this program. For that, go to Notepad. Now copy paste the code. Now save the file. The file name and class name should be same in Java, so that your Java compiler knows which class has the public static void main string args method. The file name used has to be compulsory be public for the compiler to have access. Specify the directory and save the file with class name followed by .java extension. And now our file is stored in D drive. To run the program, open command prompt. Now we are in C drive, we need to change the directory. Since our program is stored in D drive, so change to D drive. If you are saving the Java source file inside the JDK bin directory, the path is not required to be set because all the tools will be available in the current directory. In case if you have your Java file outside the JDK bin folder, it is necessary to set the path of JDK. The path is the most important environment variable of Java environment, which is used to locate the JDK packages that are used to convert the Java source code into machine readable binary format. Tools like Javac and Java can be used by setting the path. When you save your file in Java directory, that is where Java is installed, it is not necessary to set the path. But if you are saving your file outside the directory, it is necessary to set the path. There are two methods to set the path. What we are doing here is temporary path. Setting up the path temporary means when you close the command prompt or terminal, the path setting will be lost and you have to set the path again for the next time. In command prompt, type set, then leave a space and type path equals and double quote. Then go to the place where you have installed Java on your system. And locate the bin directory. Copy the complete path and write it in the command like this. And finally end this with close quote and tap enter. And this will set the temporary path of JDK. Then compile this program. To compile this program, type the command on the screen shown on your command prompt and press enter. This runs javac.exe, the Java compiler. This is a generalized command to compile any Java program. Once you hit enter, Diffie-Hellman.class file will be generated. You will find both Diffie-Hellman.java and Diffie-Hellman.class among the files on your working directory. After compilation, the .java file gets translated into .class file. The .class file is a bytecode, which is a machine language of Java virtual machine. Now we can run the program. To run the program, type the following command and hit enter. Note that you should not append .java extension to the file name while running the program. And now we got the output. The public key generated by Alice is 4 and the public key generated by Bob is 10. The secret key generated on both the sides are equal. And thus the Diffie-Hellman key exchange algorithm is valid.